When you look up at the night sky, it's easy to feel small. The stars scattered across the heavens appear as tiny, twinkling pinpricks of light, distant and unreachable. Yet, their apparent smallness belies their true nature. Each of those lights represents an immense celestial giant. These stars are cosmic powerhouses, forging the elements that make up everything we know, from the iron in our blood to the oxygen we breathe. Some of these stars are so large, so incomprehensibly vast, that they could encompass entire solar systems within their bounds. Their light, traveling across the vacuum of space for thousands or even millions of years, carries with it a story of creation, evolution, and inevitable collapse. They are not just points of light. They are monuments to the forces that shape our universe. Today, we're embarking on a journey to explore the most massive and awe-inspiring stars ever discovered. These colossal giants defy the boundaries of imagination, challenging our understanding of physics, astronomy, and even existence itself. By studying these stars, we uncover secrets about the universe's past, its present, and its future. Each one serves as a gateway to understanding the incredible scale of the cosmos, reminding us of both the grandeur of the universe and the fragility of our place within it. Number 10. Our journey begins with Rigel, a blue supergiant located approximately 860 light-years away in the constellation Orion. Known for its brilliant blue-white glow, Rigel is one of the most luminous stars visible from Earth, often outshining the neighboring stars in its constellation. With a radius about 78 times that of the Sun, Rigel is immense, but its true claim to fame lies in its luminosity, which is tens of thousands of times greater than our Sun. Rigel's brightness is fueled by its incredibly high surface temperature, which reaches an estimated 12,000 Kelvin. This is far hotter than the Sun's 5,778 Kelvin, giving Rigel its distinctive blue-white color. The energy radiating from Rigel is so intense that it illuminates the surrounding nebulae in Orion, creating breathtaking celestial vistas visible through telescopes. Rigel is not just a star, it's a cosmic beacon that lights up its corner of the galaxy. In Greek mythology, Rigel marks the left foot of Orion, the great hunter, and has been a guiding star for sailors and travelers for centuries. It has also been a subject of fascination for astronomers, who have studied its properties in detail. Interestingly, Rigel is not a single star, but part of a multi-star system. It has at least two smaller companions orbiting it, which are difficult to observe due to Rigel's overwhelming brightness. Astronomically speaking, Rigel is a relatively young star, estimated to be only 8 million years old. In comparison, our Sun, at 4.6 billion years old, is a senior citizen in stellar terms. Rigel's youth comes with a price, however. As a massive blue supergiant, it burns through its nuclear fuel at a much faster rate than smaller stars. This means Rigel's lifespan will be short on the cosmic timescale. Eventually, Rigel will exhaust its fuel and collapse under its own gravity, triggering a massive supernova explosion. This cataclysmic event will scatter heavy elements such as iron, carbon, and oxygen across its region of the galaxy, enriching the interstellar medium and contributing to the formation of new stars and planets. What remains after the explosion will likely be a dense neutron star, or, if enough mass remains, a black hole. For now, Rigel continues to shine as one of the brightest and most iconic stars in the night sky. Its radiant glow not only lights up the Orion constellation, but also serves as a reminder of the dynamic and ever-changing nature of the universe. Number 9. Next on our list is the Pistol Star, a blue hypergiant located an astonishing 25,000 light-years away near the center of our galaxy in the Sagittarius constellation. Named after the Pistol Nebula it illuminates, this star is not just a marvel of size, but also of luminosity and power. With a radius approximately 306 times that of the Sun, it ranks among the largest known stars, but its energy output is where it truly stands out. The Pistol Star shines an extraordinary 1.7 million times brighter than the Sun, making it one of the most luminous stars in the Milky Way. The Pistol Star's immense brightness is fueled by its incredible mass, which is estimated to be about 30 times that of the Sun. This mass drives intense nuclear fusion in the star's core, generating an energy output so staggering that it creates powerful stellar winds. These winds eject material from the star's outer layers at speeds exceeding millions of miles per hour. Over time, this expelled material has formed the iconic Pistol Nebula, a massive shell of gas and dust stretching several light-years across. Despite its brilliance, the Pistol Star is highly unstable. Like other hypergiants, it is nearing the end of its stellar life and is rapidly losing mass. In fact, scientists estimate that the Pistol Star has already shed about half of its original mass through its intense stellar winds. This instability makes the Pistol Star a fascinating object of study, as it provides insights into the processes that govern the lives and deaths of the universe's most massive stars. What makes the Pistol Star even more intriguing is its location near the galactic center, an area rich with extreme gravitational forces, dense stellar populations, and energetic phenomena. This region provides a unique environment for understanding how massive stars interact with their surroundings. The Pistol Nebula, for example, glows brightly due to the star's ultraviolet radiation, which ionizes the gas, creating a dazzling cosmic display. As the Pistol Star continues to shed mass and burn through its fuel, it is expected to end its life in a dramatic explosion. Scientists believe it could go supernova or possibly even hypernova, a rare and immensely powerful type of stellar death. A hypernova would release more energy than an ordinary supernova and could leave behind a black hole as its final remnant. The Pistol Star is a cosmic heavyweight in every sense of the word. Its immense size, brightness, and the iconic nebula it created make it one of the most extraordinary stars ever discovered. Though its time may be short on the cosmic scale, its legacy will live on in the materials it contributes to the galaxy, enriching the interstellar medium and seeding the formation of future stars and planets. For now, it remains a brilliant, volatile, and awe-inspiring reminder of the immense power of the universe. At number 8 on our list is Betelgeuse, one of the most recognizable and well-loved stars in the night sky. As the fiery red shoulder of Orion, Betelgeuse has captivated stargazers for centuries, both for its brilliant color and its prominent position in one of the most famous constellations. Located roughly 650 light-years away, Betelgeuse is a red supergiant nearing the end of its life, a fact that makes it not only a celestial marvel, but also a cosmic ticking time bomb. Betelgeuse's size alone is staggering. With a radius approximately 764 times that of the Sun, it is so massive that if placed in the center of our solar system, it would extend beyond the orbit of Jupiter, engulfing Mercury, Venus, Earth, Mars, and the asteroid belt. This incredible scale makes Betelgeuse one of the largest stars known, though it is far from dense. Like many red supergiants, Betelgeuse's outer layers are diffuse, resembling a tenuous cloud of gas rather than a solid surface. But Betelgeuse is more than just a giant. It's a star in flux. It is classified as a semi-regular variable star, meaning that its brightness fluctuates over time as it expands and contracts. This variability is a sign of instability in its core, where nuclear fusion is slowing down and creating heavier elements like carbon, oxygen, and eventually iron. These fluctuations give Betelgeuse a dynamic, pulsating quality, a kind of celestial heartbeat that astronomers have been studying for decades. One of the most dramatic events in Betelgeuse's recent history occurred in late 2019 and early 2020, when the star underwent an unprecedented dimming event. For weeks, its brightness dropped to just 40% of its usual level, sparking widespread speculation that it might be on the verge of exploding as a supernova. While this didn't happen, the event was a groundbreaking moment in astrophysics, providing a rare glimpse into the turbulent processes occurring in the outer layers of a dying star. Astronomers now believe the dimming was caused by a massive ejection of material from Betelgeuse, which temporarily obscured its light with a cloud of dust. When Betelgeuse does reach the end of its life, it will collapse under its own gravity, triggering a supernova explosion of unimaginable energy. For a brief time, the explosion will outshine entire galaxies, and it will be visible from Earth even during the day. This will mark the end of Betelgeuse as we know it, but the materials it scatters will enrich the interstellar medium, seeding the formation of new stars and planets. Betelgeuse has not only been a beacon in the night sky, but also a cornerstone of human culture and imagination. Its fiery red glow has inspired myths and stories in civilizations around the world, and its eventual demise will likely become one of the most observed and studied events in the history of astronomy. Until then, Betelgeuse remains a symbol of the universe's beauty, power, and ever-changing nature, a true giant that continues to fascinate us with every pulsation and flicker of its light. At number 7, we find the dazzling Mu Cephei, a red supergiant that has earned the nickname the Garnet Star for its striking deep red hue. Located near the edge of the galaxy in the constellation Cepheus, Mu Cephei is a colossal star with a radius approximately 1,650 times that of the Sun. This makes it one of the largest stars visible to the naked eye, a gem of the cosmos that has fascinated stargazers for generations. Mu Cephei lies roughly 6,000 light-years away from Earth, in a relatively quiet and sparse region of the galaxy. Despite this isolation, its rich red glow stands out prominently in the night sky, even without the aid of telescopes. Its distinctive color is a result of its surface temperature, which is about 3,500 Kelvin cool by stellar standards, particularly when compared to the blazing blue supergiants like Rigel. This cooler temperature allows for the formation of complex molecules in the star's outer layers, which absorb and emit specific wavelengths of light, giving it its unique garnet-like appearance. As a red supergiant, Mu Cephei is nearing the end of its life. Like other massive stars in this stage, it is shedding its outer layers through powerful stellar winds. These ejected materials form a glowing envelope of gas and dust around the star, a process that not only transforms Mu Cephei's immediate environment, but also contributes to the enrichment of the interstellar medium. The heavy elements produced in the star's core, such as carbon, oxygen, and silicon, are cast into space, where they will eventually seed the formation of new stars, planets, and potentially even life. One of the most intriguing aspects of Mu Cephei is its variability. Classified as a semi-regular variable star, its brightness fluctuates over time as it expands and contracts. These pulsations provide astronomers with valuable insights into the internal dynamics of dying stars, offering a glimpse into the processes that govern the transition from red supergiant to supernova. Despite its immense size and luminosity, Mu Cephei's future is finite. Scientists predict that it will end its life in a dramatic supernova explosion, scattering its elements across its region of the galaxy. This explosion will briefly outshine entire galaxies, leaving behind either a dense neutron star or a black hole, depending on the mass of its remaining core. Mu Cephei's beauty and significance extend beyond its physical characteristics. Its rich color and immense size make it a celestial marvel, a glowing reminder of the grandeur and diversity of the universe. As it continues to evolve, shedding its outer layers and pulsating with unpredictable rhythms, the garnet star serves as a symbol of the dynamic and ever-changing nature of the cosmos. Its eventual demise will mark the end of one chapter, but it will also lay the foundation for new beginnings, a true testament to the cycle of life and death that governs the stars. At number 6 on our list is the awe-inspiring Canis Majoris, a red hypergiant located approximately 3,900 light-years away in the constellation Canis Major. Once considered the largest known star in the universe, Canis Majoris remains a standout in the stellar world due to its immense size, dramatic behavior, and eventual explosive fate. This star is so vast that if placed at the center of our solar system, it would extend beyond the orbit of Jupiter, engulfing all the inner planets and much of the asteroid belt. Canis Majoris is not just large, it is dynamic and ever-changing. Classified as a red hypergiant, it represents one of the rarest types of stars in the universe. Its massive size and advanced age place it in a precarious position, where internal instability drives violent ejections of material from its outer layers. Over time, these intense stellar winds have stripped Canis Majoris of nearly half its original mass, creating a spectacular nebula of gas and dust that surrounds the star. This nebula is rich in heavy elements like oxygen and silicon, vital building blocks for new stars and planets. The dramatic loss of mass is a hallmark of the hypergiant phase, a stage where the star teeters on the edge of gravitational collapse. Canis Majoris's outer layers are so diffuse and tenuous that they resemble a cosmic fog rather than a solid surface. This makes the star's size even more astonishing, as its boundaries are defined not by sharp edges, but by a fading glow that merges into the surrounding nebula. Canis Majoris is also a pulsating variable star, meaning that its brightness changes over time as it expands and contracts. These pulsations are driven by complex processes occurring deep within the star's core, where nuclear fusion is creating increasingly heavy elements. This fusion will eventually stop when the core is dominated by iron, a turning point that marks the beginning of the end for massive stars like this one. The future of Canis Majoris is as dramatic as its present. Astronomers predict that it will end its life in a catastrophic supernova explosion, or possibly even a hypernova, a rare and incredibly powerful event. If a hypernova occurs, it could release a gamma-ray burst, one of the most energetic phenomena in the universe. Such an event would briefly outshine entire galaxies and send shockwaves of radiation across space. Despite its impending demise, Canis Majoris has already left an indelible mark on its region of the galaxy. The material it has shed will one day form new stars, planets, and potentially even life. Its nebula, glowing brightly under the influence of ultraviolet radiation, stands as a testament to the star's immense power and influence. For now, VY Canis Majoris remains one of the most extraordinary objects in the night sky. Its immense size, coupled with its dynamic behavior and dramatic future, makes it a cornerstone of our understanding of stellar evolution. It serves as both a harbinger of destruction and a symbol of creation, a cosmic giant whose legacy will echo across the galaxy long after its light fades away. At number 5 on our list is the monumental AH Scorpii, a red supergiant star that resides over 7,000 light-years away in the constellation Scorpius. With an estimated radius roughly 1/1700 times that of the Sun, AH Scorpii stands as a true colossus in the stellar world. To illustrate its size, if this star were placed at the center of our solar system, its vast atmosphere would stretch beyond the orbit of Jupiter, engulfing not only the inner planets, but much of the asteroid belt as well. This immense scale makes AH Scorpii one of the largest and most luminous stars in its class, a cosmic lighthouse shining brightly across the Milky Way. Despite its incredible luminosity, AH Scorpii is a star on the brink of its finale. Like all red supergiants, it is in the late stages of its life cycle, where the nuclear fusion processes that have powered it for millions of years are beginning to falter. Deep within its core, lighter elements like hydrogen and helium have long since been consumed, replaced by the fusion of heavier elements. This gradual buildup of heavier nuclei creates instability, leading to violent pulsations and the ejection of massive amounts of material from its outer layers. These stellar winds, while chaotic, play a vital role in enriching the interstellar medium with heavy elements like carbon, nitrogen, and oxygen, the very building blocks of life. AH Scorpii's behavior reflects its precarious position on the evolutionary timeline. The star exhibits pulsations, expanding and contracting as it sheds its outer layers into space. These fluctuations not only define its appearance, but also hint at the turbulent processes occurring deep within. Its relatively cool surface temperature of around 3,400 Kelvin gives AH Scorpii its distinctive deep red color, earning it a place among the most visually striking stars ever observed. Despite its grandeur, AH Scorpii remains hidden from the unaided eye, partly due to its immense distance from Earth, and partly because it resides in a dense region of the Milky Way crowded with gas, dust, and other stars. Observing AH Scorpii requires advanced telescopes and imaging technology, which reveal its stunningly rich hues and the faint envelope of gas and dust surrounding it, a byproduct of its mass loss. The future of AH Scorpii is as dramatic as its present. Astronomers predict that it will end its life in a spectacular supernova explosion, an event that will briefly outshine entire galaxies. This cataclysmic finale will scatter the elements forged in its core across its corner of the galaxy, contributing to the formation of new stars, planets, and possibly even life. Depending on the mass of its remaining core, AH Scorpii's collapse will likely leave behind either a neutron star, a city-sized remnant of incredible density, or a black hole, a region of space-time where gravity reigns supreme. AH Scorpii is more than just a star. It's a stellar factory, a cosmic engine, and a testament to the incredible scale and power of the universe. Its life story, like that of all red supergiants, is one of transformation and renewal, even as it approaches its final moments. AH Scorpii continues to shape its galaxy, reminding us that in the cosmos, endings are not final. They are beginnings for what comes next. At number 4 on our list is Westerlund 126, an extraordinary red supergiant that stands as a giant among giants. Located approximately 15,000 light-years away in the constellation Ara, this star is nestled within the Westerlund 1 star cluster, one of the most massive and compact young star clusters in the Milky Way. With an estimated radius over 1,500 times that of the Sun, Westerlund 126 ranks among the largest stars ever discovered, earning its place as a subject of fascination and study for astronomers. Westerlund 126's location within this dense stellar nursery makes it especially intriguing. The Westerlund 1 cluster is a bustling environment filled with some of the galaxy's most massive and luminous stars, including hypergiants, neutron stars, and other red supergiants. This unique concentration of stellar behemoths provides a natural laboratory for studying the life cycles of massive stars. Despite the brilliance of its neighbors, Westerlund 126 still manages to stand out due to its sheer size and the complexity of its interactions with the surrounding cluster. However, observing Westerlund 126 is not without challenges. Its immense distance from Earth, coupled with the dense clouds of gas and dust that enshroud the Westerlund 1 cluster, obscures much of its light. This makes the star appear relatively dim compared to other supergiants of its size. Advanced telescopes and infrared imaging have allowed scientists to peer through the cosmic veil, revealing a star of incredible proportions, glowing faintly red against the backdrop of its vibrant environment. One of the most fascinating aspects of Westerlund 126 is its irregular behavior. Like many red supergiants, it is highly unstable, pulsating as it nears the end of its life. These pulsations are caused by the chaotic processes occurring within its core, where the fusion of increasingly heavy elements is creating instability. As the star expands and contracts, it sheds significant amounts of material from its outer layers, forming a massive envelope of gas and dust around it. This expelled material not only obscures the star, but also contributes to the dense interstellar medium of the Westerlund 1 cluster. The fluctuations in brightness caused by these pulsations make it difficult for astronomers to determine the exact size and luminosity of Westerlund 126. Nevertheless, these irregularities provide valuable clues about the processes occurring inside dying stars, helping scientists refine their models of stellar evolution. The material shed by Westerlund 126 will play a vital role in enriching its region of the galaxy, seeding the creation of future stars and planets. Westerlund 126's dramatic life is nearing its grand finale. Scientists predict that it will end its life in a spectacular supernova explosion, scattering heavy elements such as iron, carbon, and oxygen into the surrounding space. The explosion will briefly outshine all the other stars in the Westerlund 1 cluster, illuminating the entire region in a cosmic fireworks display. For astronomers, this event will provide an unprecedented opportunity to study the death of a red supergiant and its impact on its environment. Until that day comes, Westerlund 126 remains a shining example of the universe's ability to create objects of immense scale and complexity. Its size, instability, and location within one of the Milky Way's most intriguing clusters make it a cornerstone of our understanding of the life and death of massive stars. This red supergiant is not just a marvel of nature, it's a gateway to unlocking the secrets of the cosmos. At number 3 on our list, Stephenson 2-18, a colossal star that challenges our understanding of the limits of stellar size and evolution. Located approximately 20,000 light-years away in the constellation Scuti, this red supergiant is one of the largest stars ever discovered, with a radius over 2,150 times that of the Sun. Stephenson 2-18 is so vast that it would engulf the orbit of Saturn if placed at the center of our solar system. Its sheer size makes it a titan of the cosmos and an object of fascination for astronomers. Stephenson 2-18 is part of the Stephenson 2 cluster, a densely packed region of space that contains some of the galaxy's largest and most massive stars. This cluster is an invaluable natural laboratory for studying stellar evolution, as it offers a concentrated environment filled with extreme examples of stellar phenomena. Despite its status as a giant among giants, Stephenson 2-18 is surprisingly dim. Its faintness is due in part to its immense distance from Earth, but also to the thick interstellar dust that obscures much of its light. Observations of this star rely heavily on infrared telescopes, which can penetrate the cosmic haze to reveal its enormous scale. One of the most intriguing aspects of Stephenson 2-18 is its immense size relative to its mass. Although it has a staggering radius, its mass is significantly lower than its size might suggest, estimated at about 40 solar masses. This discrepancy highlights the diffuse nature of red supergiants, whose outer layers are spread thinly across an enormous volume. These layers are so tenuous that they resemble a dense gas more than a solid structure, making the star's boundary difficult to define precisely. Stephenson 2-18 is also a star in its twilight years. Like all red supergiants, it is rapidly burning through the remaining fuel in its core. The nuclear fusion processes that sustain it are becoming increasingly unstable, creating pulsations that cause the star to expand and contract erratically. These pulsations are accompanied by significant mass loss, as powerful stellar winds eject material from the star's surface. This material forms a vast envelope of gas and dust around the star, contributing to the interstellar medium and seeding the region with heavy elements. The immense size of Stephenson 2-18 poses profound questions about the physical limits of stellar growth. How can a star of such magnitude maintain structural integrity without collapsing under its own gravity? The answer lies in the delicate balance between the outward pressure generated by nuclear fusion and the inward pull of gravity. As the star's core fuses heavier and heavier elements, this balance becomes increasingly precarious. Once the core begins to produce iron, a process that consumes rather than generates energy, the balance will tip and the star will collapse. When Stephenson 2-18 reaches the end of its life, it is expected to explode as a spectacular supernova, dispersing elements like carbon, oxygen, and iron into the surrounding space. This explosion will contribute to the enrichment of the interstellar medium, providing the raw materials for the formation of new stars and planets. Depending on the mass of its remaining core, the supernova may leave behind either a neutron star or a black hole, marking the final chapter in the life of this cosmic giant. For now, Stephenson 2-18 remains a fascinating enigma. Its immense size, combined with its relative dimness and instability, pushes the boundaries of what we know about stellar physics. Studying this star offers invaluable insights into the life cycles of the universe's most massive stars and serves as a reminder of the incredible diversity and complexity of the cosmos. Stephenson 2-18 stands as a testament to the extraordinary scale of the universe and the mysteries that continue to inspire us to explore. Number 2. The runner-up on our list is the awe-inspiring Scuti, a red supergiant that has captivated astronomers for decades. In the constellation Scuti is one of the largest stars ever observed, With a radius approximately 1,700 times that of the Sun, Scuti is so massive that, if it were placed at the center of our solar system, its surface would extend beyond the orbit of Jupiter. While slightly smaller than Stephenson 218, it remains an undisputed giant in the cosmos and a cornerstone in our understanding of stellar evolution. Scuti was first documented in the mid-19th century during a survey of stars in the Scuti constellation. At the time, astronomers could not have imagined the true scale of this star. Today, advances in technology have allowed scientists to peer deeper into its structure, revealing its immense size and unique characteristics. Despite its vastness, Scuti is not visible to the naked eye due to its distance and its position in a region of the galaxy dense with interstellar dust. This red supergiant is classified as a pulsating variable star, meaning its brightness changes over time as it expands and contracts. These pulsations are caused by the instability of its nuclear fusion processes, which are driven by the star's late stage of evolution. Each pulsation signals the star's struggle to maintain equilibrium as it burns through its remaining nuclear fuel. These changes in brightness make Scuti a fascinating object of study, providing a window into the dynamics of dying stars. Despite its enormous radius, Scuti's outer layers are remarkably diffuse. The density of these layers is so low that they resemble a near vacuum compared to Earth's atmosphere. This characteristic is typical of red supergiants, which swell dramatically during their final stages as their cores contract and fusion slows. As Scuti ejects material from its outer layers, it forms a vast envelope of gas and dust that surrounds the star, contributing to its immense visual scale. This ejected material is rich in heavy elements such as carbon, nitrogen, and oxygen, which are essential for the creation of new stars, planets, and life itself. One of the most intriguing aspects of Scuti is its precarious position on the stellar timeline. Scientists believe it is nearing the end of its life and is on the brink of collapsing into a Type II supernova. This event will be a dramatic and violent conclusion to the star's existence. When Scuti's core can no longer support the pressure of gravity, it will implode, triggering a massive explosion that will briefly outshine entire galaxies. The resulting supernova will scatter the elements forged in Scuti's core across its region of the galaxy, seeding the interstellar medium with the building blocks for future stars and planets. The aftermath of this explosion will depend on the mass of the core that remains. If the remnant is below a certain threshold, it will collapse into a neutron star, a dense object composed almost entirely of neutrons. If it is above this threshold, Scuti will leave behind a black hole, a region of space-time so dense that nothing, not even light, can escape its gravitational pull. Despite its inevitable demise, Scuti remains a source of awe and inspiration. Its immense size, combined with its dynamic behavior and looming fate, makes it a focal point for astronomers studying the life cycles of massive stars. Scuti serves as a reminder of the extraordinary power and beauty of the cosmos, a celestial giant whose legacy will continue to shape the galaxy long after its light has faded. And finally, at number 1, Sirius, also known as the Dog Star, is not just the brightest star in the night sky. It's a stellar phenomenon that has captivated humanity for millennia. Located in the constellation Canis Major, Sirius is a binary star system composed of Sirius A, a main sequence star, and Sirius B, a dense white dwarf. Together, they offer a fascinating glimpse into stellar evolution and the complexities of binary systems. At just 8.6 light-years away, Sirius is one of the closest stars to Earth, making it a key focus for both professional astronomers and casual stargazers. Its brightness, with an apparent magnitude of 1.46, is largely due to its proximity and intrinsic luminosity. Sirius A, the primary star, is about 25 times more luminous than the Sun and has twice its mass. Its intense energy and brilliance have earned it a prominent place in human culture, mythology, and science. What makes Sirius particularly fascinating is its binary nature. Sirius B, the white dwarf companion, is the remnant of a star that has already completed its life cycle. About the size of Earth, but with a mass nearly equal to the Sun, Sirius B is one of the densest objects astronomers can observe directly. It offers a rare opportunity to study the afterlife of stars and understand the processes that lead to their collapse and transformation. Historically, Sirius has been revered by civilizations worldwide. In ancient Egypt, its heliacal rising, when it first became visible in the dawn sky, coincided with the annual flooding of the Nile, a critical event for agriculture. To the Greeks and Romans, Sirius was associated with the dog days of summer, reflecting its position in the constellation of Canis Major. Indigenous cultures and Polynesian navigators also relied on Sirius as a celestial guide. In modern science, Sirius has played a pivotal role in advancing astronomical techniques. Observations of its binary motion provided early evidence for the existence of white dwarfs, helping to confirm theories of stellar evolution. Moreover, its brightness and proximity make it an ideal candidate for studying stellar atmospheres and the dynamics of binary systems. Sirius also holds an aesthetic appeal. Its shimmering appearance, often twinkling with rainbow-like colors due to atmospheric turbulence, makes it a standout in the night sky. It has inspired poets, artists, and scientists alike, symbolizing both beauty and discovery. In essence, Sirius is more than just a star. It's a cosmic marvel that bridges the gap between ancient mythology and cutting-edge science. Its brightness, proximity, and dual nature as a binary system offer endless opportunities for exploration and inspiration, securing its place as one of the most fascinating stars in the universe. A tribute to cosmic wonder. These stars are not just celestial objects. They are monuments to the extraordinary scale, power, and beauty of the universe. Each one tells a unique story, a tale of creation, struggle, and inevitable transformation. From the youthful brilliance of Rigel, blazing with unmatched intensity, to the quiet yet awe-inspiring decay of Betelgeuse as it approaches its supernova finale, these stars remind us of the cycle of life that governs all things. Their fiery births, tumultuous lives, and dramatic deaths mirror the processes that shape the universe itself, a constant balance of destruction and renewal. Each of these stellar titans is a cosmic beacon, illuminating not just the night sky, but also the vast expanse of time and space. Their light, traveling across unimaginable distances, carries with it the history of a universe that existed long before humanity. Some of these stars were born before Earth itself formed, their light a time capsule of ancient events. They connect us to the distant past and serve as a reminder of the forces that brought us here. In their brilliance, we see not only the majesty of the cosmos, but also our own place within it. They inspire us to dream, to explore, and to question what lies beyond the edge of the visible universe. How did these celestial giants come to be? What mysteries remain hidden in the stars that are yet undiscovered? These questions push us forward, fueling the curiosity and wonder that define humanity. The stars are not just distant orbs of light. They are the keys to understanding the origins of everything we know. But perhaps most remarkable is how these stars make us feel. Their sheer size and power are humbling, yet they evoke a sense of connection to something greater than ourselves. Despite their vastness, they remind us that we are not isolated in this universe. The very atoms in our bodies were forged in the hearts of stars like these, scattered across space in supernova explosions, and reassembled over billions of years into the life we know today. The stars are not just out there, they are a part of us. So the next time you look up at the night sky, pause for a moment. Reflect not just on the staggering size of these celestial giants or their unfathomable power, but on their ability to bridge the infinite and the intimate. In their light, we see the echoes of creation, the energy of life, and the promise of a universe filled with endless possibilities. The cosmos is vast, its mysteries seemingly endless, but within its vastness lies one undeniable truth. We are part of something extraordinary, a grand story written in the stars.